Hey, grade sevens, last video lesson of the year. Amazing. Um, Last lesson, we went over section 12.1 and 12.2 on mean, median, and mode. Make sure you watch that before doing this one, because this one, some of it will make sense unless you've watched that or learned about that from me or textbook or other places. And today we're going to do 12.3 and 12.4. We're not going to do 12.5 at all. And we're looking at range and outliers. So these are the two new terms that you need to learn. So the range is the difference, which means that you're going to have to be subtracting, between the largest and the smallest values in a set of data. Okay, the difference between the largest and the smallest values in a set of data. We will go over how to find that. And an outlier is a value that is either much smaller or much larger than the other data values. Okay, there could be one outlier, there could be more than one outlier, or there could be no outliers. And you could have a set of data that is all relatively close together. It doesn't mean that you have to, just because there could be an outlier, doesn't mean there has to be one. Okay, so let's just look at range, what range means. So the following diagram, we have this diagram here, shows the elevation changes for the stomach bender roller coaster. So the measurements represent the heights of the roller coaster relative to the starting point of the ride. So if you were to start here, you could say that you're at 0 meters, and then it goes over the change in elevation from that point. So this is sort of a representation of how we can see range. So this is the starting point. We have a few data points here. We have 0 meters, starting point. We have -6, so down here it gets to -6 meters. Up here is this. It gets up to 32 meters, so that's at 32 meters high. Okay, so like 100 feet. Gets down to -3 meters. 18 meters is here, and -21 is here, and then the end is back at 0. So we have these values that we could see, and if you had any set of data, you could sort of put it onto sort of like a graph like this a little bit. But the range that we're finding out is, well, what's the difference between the highest point here and the lowest point, which is in line with E here. So what is this difference, the total height from the lowest point to the highest point? That tells us the range. And we find it by just subtracting those two numbers. We take the larger number and we subtract the smaller number. So the larger number here is 32 meters, and we subtract -21. So we subtract -21. Okay, now if you remember, subtracting a negative is the same as adding the positive. So this is the same as 32 meters plus 21 meters, which makes sense because if we're trying to find this whole line, we would take this 32 meters and we would add to it this 21 meters, and that would tell us the total. But it's the same as subtracting the negative. So in total, the range of this roller coaster would be 53 meters. Okay, and so the range of those data points would be 53. So that's really what we're finding with the range, is just the difference between the largest and the smallest. So what is the range of each of these set of values? So for A here, what you do is you find the biggest value. I look through it, I find 8. So 8 is my biggest. I subtract from that the smallest. The smallest one I see is 2. So 8 minus 2 is equal to 6. Okay, so the range for A would be 6. For B, find the biggest one. Well, it's this first one here. It's the 11. I then look for the smallest one. It is right here, the 5. Biggest number, subtract the smallest number, shows you your range, which is just showing us how spread apart our data is. Okay, so 11 minus 5 is 6 as well. And C, our largest number in this case is 3. Okay, so it's positive, and our smallest one is -4. So 3 minus -4 is equal to, well, that's the same as 3 plus +4. There's 7, a difference of 7 between those two numbers. Okay, so looking at the spread between the largest and smallest number, that's what we're doing with the range. Okay, hopefully that makes sense. Outliers. So outliers are just numbers that sort of are outside of the norm. They're either much larger or much smaller. It doesn't mean that it's bad if there's an outlier. It isn't always necessarily wrong. But sometimes an outlier shows that maybe a mistake was made. It doesn't mean you should take it out of there. If it shows that a mistake was made, then maybe you would. But you can keep outliers in the data. It's just important to notice how they affect it. So for example, in the 1985-1986 NHL hockey season, which is shown here, okay, Wayne Gretzky set a record for the most points. So his goals plus assists, he had 215 goals plus assists, which is crazy. Because nowadays, if you break 100, that's very good. I mean, obviously back then, even there weren't that many guys breaking 100. And this table shows the top 5-point leaders also for the 1985-86 season and also the 2005-2006 season. Okay, so we have sort of two sets of information, so split down the middle here. So on the left side, 1985-1986, then 2005-2006. So determine the range for each season. Compare the two ranges. So the range for this season would be the biggest number, Wayne Gretzky at 215, subtracting the smallest number. So 215 minus 123 gives us a range of 92-point difference between Wayne Gretzky in first and Mike Bossy in fifth. In the 2005-2006 season, we have Joe Thornton in first with 125. We find this range, 125 minus 103. Okay, and there's a 22-point difference, which is pretty significant differences between these ranges. So Wayne Gretzky was 92 points ahead of the guy who was in fifth place in the points race, and Joe Thornton was only 22 points ahead of the guy who was in fifth place. When you look, this would have been 20 years later. Okay, so these are two ranges. One of them is much larger than the other. So which data value appears to be an outlier in one of the two seasons? Well, really the one outlier that we see is Wayne Gretzky's point number, which is 215. He's the only person in the 200s. Everyone else is below 150 even, between 100 and 150. So his is definitely an outlier. Okay, so what if we remove the outlier and then determine the new range for the last season? So let's say we took away his 215. Now what would the range be between Mario Lemieux and Mike Bossy? Well, 141 minus 123 gives us a range of 18. And now we see, when that outlier is removed, that the ranges are much closer together. So besides Wayne Gretzky in that 1985-1986 season, the differences between those top players in their number of points scored is pretty similar. And you could imagine maybe there'd be someone below Mike Bossy who would only be a couple points behind him, and the ranges actually might have even been the exact same for the top 5 players if we took out Wayne Gretzky. Okay, and so we can notice that an outlier can have quite an effect on the range of a set of data. It can also have quite an effect on the mean, median, and mode, which we will see in a little bit here. Okay, so that's outliers, numbers like Wayne Gretzky. What values appear to be outliers in each set of data here? Okay, let's just read these off in A. There's 18, 19, 79, 17, 20, and 12. Well, if you look at this, I would say 79 would be an outlier. All the rest of them, you know, the range is between 12 and 20, which isn't very far apart. They're only 8 apart. Whereas 79 is you're looking at another 60 point difference there. So 79 would be an outlier in A. In B, 14, 14, 16, 15, 1, and 16. I would say 1 is an outlier for sure. It is only, 13 away from 14, which isn't as much as in A, 79 being, close to 60, well over 50 away from the next highest number. So this is only 13 away, but all the other numbers are very close together. 14, 15, 16, they're all right beside each other. And so to have 1, that shows that there's an outlier. Now, if in this set there had been a couple other numbers, let's say that there was an 8, maybe a 12, maybe a 5, and let's say a 3, all of a sudden 1 being an outlier, well, not quite as much because it has this other data that sort of slowly connects it to these other numbers. Okay, but since it is the only one in B, and that is not right beside the others, that would be the outlier there. Okay, and then C, 98, 202, 99, 91, 2, 95, 89, 88, 94. Which one of these could be outliers? Well, most of these numbers are in the 90s or very close to the 90s with 88 and 89. We have two numbers, 202, which is about 100 away, and we have 2, which is again almost 100, more than 80 away from the next number. So in this case, we do have 2 outliers. Okay, so just finding the numbers that are not really close and do not fit with the rest of the numbers. So key ideas: the range provides information about the spread of the data. So this is the equation to find range, which you need to know. And outliers are values that are very different from the rest of the numbers in the set of data. And there can be no outliers, 1 or more outliers. Okay, range and outliers. So let's look at the effect of outliers, how outliers affect our measures of central tendency. So how they affect our mean, median, and mode. Okay, so let's look at basketball shooting. Shannon practiced shooting baskets every day last week to prepare for a basketball tournament. She recorded the number of baskets she made each day, so out of 25 shots. So what is the range of the baskets she scored? So she shot 25 buckets each day. What is the range of how many she scored in the week? Well, the most amount she scored was 22. So we'd go 22, and then we'd subtract to that the least amount, which is 5. So 22 minus 5, which gives us 17. So the range is 17 between the highest and the lowest. What are the median and mean numbers of baskets scored? Okay, so for B, when we're finding let's find the median first. The median is the middle, so we're going to need to arrange these from smallest to greatest. So 5, and then 14 it looks like, and then 16, then 17, and then 18, and then 20, then 22. So which one of these is in the middle? Well, okay, 17. 17 is the median here. Okay, and the mean would be that we add them all together. Okay, you add all your numbers together, 14 plus 17 plus 16 plus 20 plus 5 plus 22 plus 18. And then whatever that sum is, you divide it by how many numbers we have, which is 7, because there's 7 days of the week. So we divide that by 7. So I'll just quickly add that on my calculator. 14 plus 17 plus 16 plus 20 plus 5 plus 22 plus 18 is 112. I divide that by 7, and I get an answer of 16. Okay, so our median is 17 of all of these values, and our mean is 16. Okay, so identify any possible outliers. Should the outliers be removed from the data set? Well, should the outliers be moved? So she definitely has an outlier. On Thursday, whatever, she was having an off day. She only hit 5 out of those 25. On every other day, her lowest was 14. So, that's a decent amount, but 5 was, well below 50%. She's only looking at 20% there. So is that an outlier that should be removed? Well, it doesn't mean it should be removed just because it's low. If a NBA player has a really bad game and his stats are really bad, people don't just say, "Oh, well, remove that game from his stats," because you need all the stats, both the good and the bad games, to make up a person's total average of their stats. So it doesn't mean we should remove this, but it is interesting to see that if we did remove it, so let's say that we removed the 5 from finding the mean, that her average would go up, her mean would go up quite a bit. Okay, so it definitely changes. Having that 5 in there affects it quite a bit. We'll see that again in a second. Okay, so these following times were recorded in seconds for runners in a race. Okay, so this was each of the times for each of the runners in their race. So what is the range of times? Well, we find the biggest time, 40.4. We subtract from that the smallest time. Let's find here, who had the fastest running time? Looks like 16.5, if I'm not mistaken. And we subtract those, 40.4 minus 16.5, and we get 23.9 is our range. So what are the median and the mean times? So to find the median, we again have to arrange them all in order. So let's find that lowest, so 16.5, and then 17.1. So median means middle, so we have to have them in order. Then 18.5 it looks like, and then 19.0, and then 20.2, and then 20.5, and then 21.4. Okay, do I have enough? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, 1, 2, 3, 4, 5. Oh yeah, I'm missing some here. Oh yeah. 24.5. I just didn't keep going. I thought I had them all. 24.5 and 40.4. So I'm way behind there. Okay, so the median and mean time. So the median of these 9, as we find the middle number, since there's 9, the number would be the 5th number. The median is equal to 20.2. That's the middle number of all those. The median equal to 20.2. And now when we find the mean, numbers for the mean, we add these all together. So add them all together, then divide by 9, because there's 9 runners. So I'm just going to add on my calculator, 16.5 plus 17.1 plus 18.5 plus 19 plus 20.2 plus 20.5 plus 21.4 plus 24.5 plus 40.4. So that adds it together to 198.1. We have to divide that by the 9 runners. Divided by 9, we get 22. So the mean, 22.01. So we can say 22.0. So the mean is higher than the median. And even though this median shows the middle one, the mean is higher since this one number, 40.4, is so much higher above the others, so much higher above that, the middle of the rest, that it sort of pulls that average up. So when you have one number that's quite a bit higher than the others, it affects that mean the most. It brings that mean up. It didn't matter. Whatever number this 40.4 was, that doesn't matter. It doesn't change which one is the median. The median stays the same. But if that big number changes, it really changes the mean. So the mean can be greatly affected by any outliers. So are there any outliers? Yes, sure. This 40.4 is an outlier. They went, you know, almost twice as slow as the median person. Should it be removed? No, you just have a slow person, and that data should reflect that. However, let's say you had one of these numbers that said 2.56 or something like that. That should probably be removed because that's actually probably a mistake. And that should probably say 25.6. But whatever time race this is, I'm guessing there's no one able to run it in 2.56 if the next fastest person was in 16.5 seconds and everyone else was near 20. Okay, so if the outlier seems like it's a mistake and shouldn't be part of the data, then you should take it out. But if it's a valid piece of data, you got to keep it in. Okay, so there's one more example showing how an outlier can affect the mean so much, the average. So if you have 10 people's annual salary, and there's 22,000, 35,000, 45,000, 60,000, 65,000, 75,000, 100,000, 110,000, 130,000. So far, that has a range, you know, of I mean, over 100,000, but a range that is reasonable for what most people make. You know, 22 grand a year is maybe quite low, but you know, when I was a student, that's more than I was making a year. Like in university, and 130,000, hey, that's a good salary. Not ridiculous, but more than quite a few people make. But this last one here is 16 million, which there are some people who make that. So if you had these 10 people and you said, oh, well, what's the average amount that we all make? How do these get affected? Well, let's look at the mean and the median here. So the median would be in the middle. So if 10, that'd be between the 5th and the 6th. So 1, 2, 3, 4, 5. So here's between 5 and 6. So the median is between 65,000 and 75,000, which is 70,000. Which 70,000 seems like a pretty reasonable representation of what most of these people in this group are making. So let's find our mean. So if you were to add all of these salaries up, they would add up to 16 million, which is what this guy's making, $642,000. Okay? So we have to divide that, because that's that total amount, by the 10 people. So when we split that among the 10 people, we get a mean of 1.66 million dollars. Okay, so we look at this. We look at these 10 people. We say, and if someone would say, "Oh, what's the average salary that you 10 people make?" and someone knew it, said, "Oh, the average salary we make is 1.66 million." That number makes it sound like everyone there is really rich and really well off. But the fact is, it's not the case. Some people are actually not making very much money. Some people are making a decent wage, but not a crazy amount. There's just this one guy who's making a ton of money, and that totally skews the mean, the average. And so the average you can't always just use an average or look at an average and say, oh, well, that gives us a clear picture of the data, because it doesn't. Mean often seems like the best choice, and often it is the best choice to find the measure of central tendency. But in this case, which one's the better measure of central tendency, median or mean? Well, median, I think, of 70,000 is a better representation of the middle of what the salary is for all of these people. Because this one guy making 16 million, that just skews our average so much. Okay, so it's just an important thing to look at. That's why we have mean, median, and mode, so that when you look at data like national averages for salary, if you just look at the mean, you have to remember that those number of very extremely wealthy people, that bumps up the mean quite a lot. And so looking at the median and the mode can actually be more useful. Okay, so just something to be aware of, that these outliers, these very large numbers in a set of data, can really affect the mean affect the average? Okay, and that's pretty much the key ideas. Outliers, they can affect all measures of central tendency, because obviously when you have that outlier in there, it changes where the median is. But it mostly, the mean is usually affected more by an outlier than the median. Okay, so some outliers are just as important as other data values, while others are better removed from the data set. Okay, and that's just sort of a judgment you have to make as you're looking at data. Okay, and that's that. So outliers and range are the two things you have to know. I'm just looking at it, how outliers affect our measures of central tendency. And that is that, grade 7s. I will be around if you need help.